Welcome to the Explainer. Today, we're doing a real deep dive, putting two of NVIDIA's most powerful GPUs head-to-head. We're going to figure out which one is the right choice for your AI ambitions, the professional-grade RTX 6000 Ada or the consumer champion, the RTX 4090.
Okay, let's just jump right into it. This is a question facing countless developers and AI enthusiasts out there. Do you invest in the purpose-built workhorse for those mission-critical tasks? Or do you go for the record-breaking consumer card that's pretty much opened up high-end AI development to everyone? And you know what? The answer? It really depends on what they're trying to build.
So first up, let's meet our contenders. On the surface, they might look like they're from different planets, but they are both titans, born from the very same revolutionary Ada Lovelace architecture. Yeah, they share the same powerful DNA. That includes NVIDIA's fourth-generation tensor cores, which are basically these little superchargers for all the math that powers AI. But here's the thing. Even though they're family, they were engineered for totally different missions. One for rock-solid professional stability and capacity, the other for raw, accessible performance. Here's a great analogy for you. Think of the RTX 4090 as a precision race car. It's built for just blistering speed on the track. The RTX 6000 Ada, on the other hand, is like a commercial haulage truck. It's engineered to carry massive loads reliably 24/7. Both are incredibly powerful, just for very different jobs. Okay, this is where it gets really interesting. When you look at the spec sheet, that's where the story of their different design philosophies, well, it just jumps right off the page. Let's break down the numbers that really matter for AI. The crucial point here is the trade-off, right? The RTX 6000 Ada gives you double the VRAM and hardware-level ECC, that's error correction code, which is huge. It stops those tiny memory glitches that can totally ruin a long-running AI job. But the RTX 4090 is a fraction of the price. And you can see the power difference too. The 6000 Ada is way more efficient at 300 watts, which makes it perfect for multi-GPU workstations. So, both cards have those awesome 4th-gen tensor cores. And here's the really big deal. They both support the FP8 data format. Now, what is FP8? Just think of it like this. It's a way to use smaller, kind of less precise numbers for all that AI math. And because they're smaller, you can process way more data at once. It's a total game changer for large models like the transformers that power things like ChatGPT. So, just how fast are they really? The RTX 6000 Ada delivers a mind-blowing 1.46 petaflops of AI performance. I mean, to put that into perspective, we're talking about over a quadrillion calculations every single second. NVIDIA specifically aims this card at heavy professional transformer workloads, and yeah, this number shows you why. And look at this, the RTX 4090 is right on its tail, offering up to 1.32 petaflops. The performance is incredibly close. This kind of power at this price point is literally what's let so many of you jump into high-end AI development. It's been a revolution. But here's the twist. For the massive, complex AI models we're all trying to run today, raw speed, it isn't the whole story, not even close. The real bottleneck, the thing that'll make or break your project, is memory. And boom, this chart says it all. This is the single biggest difference between these two GPUs. The RTX 6000 Ada has a massive 48 gigabytes of VRAM, a full 2-to-1 advantage over the RTX 4090's 24 digs. So why does that memory gap matter so much? Well, because today's state-of-the-art large language models are just incredibly memory hungry. A 70 billion parameter model like Llama 3, even when you shrink it down with a process called quantization, still needs about 40 gigabytes of VRAM just to load. And this is where things get really clear. The RTX 6000 Ada can load that entire 70 billion parameter model into its own super fast VRAM. It's like having every single tool you need right there on your workbench, within arm's reach. The RTX 4090, well, it just doesn't have the space. It's forced to constantly run back to the garage, your computer's much slower system RAM, to fetch the parts it needs. And that slows everything way, way down. In a real-world numbers, man, they don't lie. For the smaller models, they're basically neck and neck. Both are screaming fast. But when you try to run that monster 70 billion parameter model, oh boy, it's a totally different story. The 6000 Ada keeps chugging along with usable performance. The 4090, because it's constantly offloading to that slow system RAM, just crawls. Okay, so with all that laid out, how in the world do you choose?
Let's break it down and find your perfect match.
Look, if you're in an enterprise setting, working for a company that's deploying these huge AI models, and reliability is everything, absolutely non-negotiable, then the RTX 6000 Ada is your tool. Its massive VRAM, that ECC protection, and the Pro drivers are all designed for mission-critical 24/7 operation, period.
But what if you're the innovator, the individual researcher, the startup, the small team trying to make a big splash on a budget? Well, the RTX 4090 gives you incredible democratizing power. It's perfect for smaller models, for image generation, and yeah, even for dipping your toes into those larger models if you can live with a performance hit from offloading.
So, let's land the plane here. What's the final verdict? Ultimately, there isn't a single better GPU. The right choice is the one that perfectly matches your workload, your budget, and your goals. It really just boils down to one simple question you have to ask yourself. Are you prioritizing professional-grade capacity and guaranteed stability for large-scale production? That's the RTX 6000 Ada. Or are you looking for unmatched power per dollar for your own research, development, and experimentation? That's the RTX 4090. Now, if you're a data geek like me and you want to dive even deeper into the numbers, see more benchmarks on different models and things like that, you can find the full, detailed analysis from our source linked right down in the description. And that just leaves us with one last kind of scary thought to chew on. Today, 48 gigabytes of memory feels absolutely massive. But as AI models keep growing at this exponential rate, how long is that going to last? Is 48 gigs already the new minimum for serious work? What's it going to be next year? Something to think about.